So now I guess we'll start with the essential questions from section 4. You will need to know what's the difference between an element and a compound. Where do you find elements? What is that called? On the periodic table. So anything that's found on the periodic table is an element. A compound is 2 or more elements chemically combined. How is the periodic table organized? And then here are 2 vocab words, law of definite proportions and law of multiple proportions. What's the difference between the 2? They are not the same, and you'll need to know the difference. So, new vocab, we'll go over all of those. So, first one, first pure substance is an element. An element can't be broken down into something simpler. It's a pure substance, so if I have zinc, I can't break it down into anything. Zinc, 1 atom of zinc is the smallest particle of it I can have. I can't break it into any other substance. Hydrogen is pure hydrogen. I can't break it into anything else. It's in its simplest form. 92 elements occur naturally on Earth. Each element has a unique name and then a symbol that goes with it. Very important when you write your answers, if I ask you to write a symbol, so the symbol for iron is Fe. You always capitalize the first letter, and then the rest are all lowercase. So make sure, I don't want to see this for iron, I don't want to see this for iron. 1 capital letter, 1 small letter. Make sure that you write them the correct way. And it seems like I have more issues. Some people just like to write in big letters. Make sure you don't do that with your symbols. The ones that are not naturally found on Earth are made in a laboratory, and a lot of them are found towards the bottom of your periodic table, and a lot of them have names. So like californium was made in California. Mendelevium was named after Mendeleev. So a lot of the names kind of give you a hint to where they come from. So all the elements are found on the periodic table, which I believe you have a copy in the back of your book. And I will also at some point in time hand out a copy of a periodic table that's my favorite. So the periodic table organizes elements into horizontal rows are periods, and vertical are columns. Also called groups, and also called families. So periods go across, groups and families go up and down. So if you look at your periodic table, flip to the back of your book where there's a periodic table, name an element that is in the same group as sodium. Potassium. Name one other one. Lithium. So sodium, potassium, lithium are all in the same family, all in the same group. They are going to have similar characteristics. Name something that's in the same period as carbon. Boron, nitrogen, oxygen, fluorine. So periods go across, groups go up and down. Elements that are in the same group have similarities. Elements in the same periods do not. That's why groups are called families, because they have similar characteristics. Periods do not have similar characteristics. And the table is called periodic because periodic basically means pattern, and we will study that the periodic table is set up a certain way because of certain patterns that are found in it. So element, very simple, on the periodic table, one thing. A compound is made up of two or more elements chemically combined, not physically, not mixed. There has to be a reaction that combines them. Most of the matter in the universe exists as compounds. Some common examples: NaCl is table salt, H2O is water, there's tons. Anything that has a formula is a compound. Unlike elements, compounds can be broken into their smaller components. So how do I break water into hydrogen and oxygen? Anybody know? I can do it with electricity. It has to be some kind of chemical change to break it apart. So if you put electricity through water, you can actually bring out the hydrogen gas and the oxygen gas, and you can break it apart. Some of them too, you can maybe burn off some of the, if I burn things, I can find some of the other elements that are found in it. So a compound can be broken into its simpler elements. However, here's an example. Here's the electrolysis that I was talking about. I can put electricity through. So separating a compound often requires external energy. Like I said, sometimes you can burn things and cause changes. You can use electricity. This is an example of how you would actually set it up. So here's water, here's hydrogen, and it depends on whether you have the positive or negative end of the battery, whether you'll get hot, oxygen or hydrogen bubbles. Also, DNA, when you do electrolysis in biology, that basically works on the same principle. Here is something very important. The properties of a compound are different than the elements that make it up. So for example, NaCl stands for what? Table salt that you put on your French fries. Sodium by itself is explosive. If I put it in water, it will burn, and I've put it in a petri dish before and it'll bubble and pop, and it's very, very reactive. Chlorine gas is used to kill people. It is used in warfare. It is toxic. So, does table salt have any of the characteristics of the elements that make it up? No. And that's something very important. The properties of a compound are totally different than the elements that make them up. Hydrogen gas, very reactive. Oxygen gas, used for breathing mechanisms. Water is a liquid at room temperature. Water is nothing like the hydrogen and oxygen that make it up. So when they are chemically combined, it makes them very different. So here is kind of an easy way to look through the different kinds of matter. We'll either have mixtures or pure substances. That's the two main groups. Pure substances, all you can have is elements and compounds. That's the only choices there are. And under mixtures, there's heterogeneous and homogeneous. Remember, homogeneous is going to look the same throughout, even alloys. I can take a couple metals, melt them, put them together. Heterogeneous, dirt, blood, milk, have different action. And milk, in my milk, I would accept in either area. The milk that you guys drink out of a carton is homogenized. If you read that on your carton, that means that it has been mixed so well that it is homogeneous. If you live on a dairy farm and you milk the cow and put that in the fridge, the cream is going to rise to the top, and that's why milk is put under heterogeneous here. The milk that you drink at school is homogeneous. which is good because I don't like chunky stuff. Alright, law of definite proportions, law of multiple proportions. You'll need to know the difference. Law of definite proportions states that one compound is always composed of the same element in the same proportion of mass, no matter how large or small the sample. So water is H2O, and the ratio is always 2 hydrogen to 1 oxygen, no matter if I have 50 gallons of water, 2 gallons of water, 1 drop of water. Law of definite proportions, the formula for something is always the same. Peroxide is H2O2. So notice the proportion is 2 to 1. Here it's 2 to 2. Gives me something different. Peroxide is always this. Water is always that. Definite proportions. The relative amounts are expressed as a percent by mass, and then the ratio is given. There are some practice problems in your book that go over this that you can practice, and there's a little tutor part in your online portion that goes over this as well. And we'll look at that. So definite proportion, one substance, always the same. So here I can see I have granulated sugar, I have sugar cane sugar. Basically they're both sugar. I have 20 grams and I have 500 grams. If I have 20 grams, 42% is carbon. If I have 500 grams, 42% is carbon. It's going to be the same all the time because it's made of the same stuff. So here's a table showing the percentages are always the same if I have the same substance. Because the formula is the same. It can't be different. Law of multiple proportions now looks at when I compare different things. So it states that when different compounds are formed by the combination of the same elements, different masses are going to combine at different ratios. So here again I can look at peroxide and water. But this time I'm comparing them. I'm looking at two of them. They both have hydrogen and oxygen, but they are not the same proportion. Here I have a 2 to 2 ratio. Here I have a 2 to 1 ratio. Different compounds made of the same elements. Hydrogen mass should be the same in both, but the oxygen is going to be twice as much in peroxide as it is in water. So if I look at a table like this, so I have CuCl. I have copper and chlorine. If I look at this, here's my percentages. Are these compounds the same? Nope, the percentages are different. So if I get over here to my mass ratio, if I round this up, this would be Cu2. I would have 2 copper to every chlorine. For this one, I'd round that up to a 1, so I'd have 1 copper and 1 chlorine. So both of them have copper and chlorine in it, but their proportions are different. They are not the same. They are not the same compound. So that's multiple proportions. And that's pretty much everything. So vocab, make sure you know definite, multiple, make sure you can do percent by mass. We'll do a couple of those practice problems. Periodic table is ordered in families or groups, up and down. Periods go across. Element is one thing, compound is more than one. And that's pretty much the last section.